In order to improve the recursive change algorithm, we can use the same strategy what we have used for improving the Fibonacci problem. And we have to rely on the fact that we can calculate the m number of coins, means the minimum number of coins for m, by calculating the m minus c1, m minus c2, and so on. And we can also reverse this order and reverse the computing, and we can find the minimum number of coins, and it will take less time and less work. And by doing so, we will not recalculate the already computed problems, and by using the solution of that problems, we can find the solution of a bigger problems, and it will save the time and the recomputation of the already computed problems. So if we want to calculate the minimum number of coins, that is m, for doing so we have already selected the harder task for calculating the money m from 0 to m, and by doing so it will require much work, but actually it will solve our problem and simplifies the matters. Further, if we will see the algorithm with the running time of omega, big O, m and d for calculating the minimum number of coins, and we know that the best number of coins we can calculate for a given value of m, and this value is much better when we take the value which is less than m. Now we will see the dynamic problem change algorithm, and D and P means the dynamic problem change algorithm, and same parameters. M is the change we want to return, C is the number of coins, and D is the denomination. So the first step is we assign the value of 0 to best number of coins, and in the second step for loop will apply and will assign the value 1 to m to small m, and then we will calculate the best number of coins m, that is infinity, and then for loop will apply, and we have in the previous recursive algorithm we have also seen this, we applied the value 1 to d to I, and if loop will again apply, and if the value of m is less than or equal to ci, then again the if loop will apply, and we will see if the value of best number of coins m minus c1 plus 1, again we have seen that it is my 77 minus 1 cent, we will get 76 plus 1, so it means that this is plus 1, here we get it. And if it is less than best number of coins m, then best number of coins m minus c1 plus 1, we will assign this value to best number of coins, and we will return the answer best number of coins m. So in this algorithm we can see at step number 6 there is no recursive call, and this is the main difference between the dynamic programming algorithm and the recursive algorithm, that in the dynamic problem algorithm there is no recursive call, and this algorithm will use the already computed solutions to further analyze the answer of the other solutions, and it will combine all these solutions to find the answer of the bigger problem. So we can see here the main differences between the recursive change and the dynamic change. The first one, recursive change, it recursively call d again and again, and then compute the best change for m. So when it is calling the d again and again, it will take lot of time. But in case of dynamic problem change, it analyze the d already pre-computed. So it will not analyze it or call the D recursively again and again, but it will use the pre-computed values and it will instantly compute the new one on the basis of the pre-computed values. So it can be a surprise that simply reversing the order of computation makes a dramatic difference in efficiency. And we know that we have seen in the previous slides that we have computed the 77-cent problem into a 77-cent problem into 70 cents by -1 cent, then 3 cents, and then 7 cents. And this process was continued again and again. And we started from high to low value of the coins. But we will see by reversing the order in this direction, we can save much time. So the difference between the complexity of a problem and the complexity of an algorithm, we can see here that the initially running time of the algorithm is big omega m raised to power d denomination in this algorithm, and it solved the change problem. And it not appear no easy way to the remedy. And we can see dynamic problem change algorithm provides even the simpler method, and its running time is big O m into d solution. So by slightly modifying the change problem renders the problem very difficult. So there is a very slight change in these, but the running time will be much different. So if we had a limited number of each denominations and needed to change m cents using no more than provided supply of each coin, even then we have fewer possible choices. It would seem to require even less time than the original change problem. And then the minor modifications to dynamic problem change, it will be very beneficial. So we can also see the limited number of each denominations are needed to change m cents, and we will simply see the minor modifications in the dynamic problem. We will see in the next slide what minor modifications are. So minor modification is just we have inverted the problem. So we started from 0, we added 1 coin, and if we minus 1 coin, because we have only 1, 3 and 7 cent coins. If we have again added 2, we have only one choice. We added 3, we can have two choices. We either minus 1 coin from 3, it will do equal to 2, and we can minus 3 minus 3 equal to 0. So we have two choices here. So whenever we add 1 coin, we have the choices. So here in this case we have two choices, -1, -3, and in this case we have three choices. 7 minus 1 is equal to 6, 7 minus 3 is equal to 4, and 7 minus 7 is equal to 0. So again we have 1 cent coin, 3 cent coin, and 7 cent coin. So we can see here 7 minus 1 6, 7 minus 3 4, and 7 minus 7 is 0, and so on. So if we want to compute the 9 cent problem, we can compute it very easily. Despite going in this direction, starting from 77 coin, we just started from 0 and we end up with 9 cent problem, and we can easily compute it.